All right, welcome back, 8th grade. We've got our next problem in our new book. It's in the system. We're looking at problem 1.2. We're going to be connecting those two different versions of those functions that we've been looking at for linear equations. All right, here we go.
All right, here it is, 1.2. Connecting ax plus by equals c and y equals mx plus b. So there are two common forms of linear equations with two variables. When the values of one variable depend on the other, it is common to express the relationship as y equals mx plus b. This equation is in slope-intercept form. That's not new for us. We've been working with that for a long time. When the values of two variables combine to produce a fixed third quantity, you can express the relationship as ax plus by equals c. This equation is in standard form. This is one we talked about the other day. The equations in problem 1.1 are in standard form. The graph of each type of equation is a straight line. Since you know a lot about the graphs of linear functions, it is natural to ask, given an equation in one form, can you write the equation in another form? As you work on this problem, look for the connections between the two forms of linear equations. Okay, so we spoke about it in the Google Meet, we spoke about it in the video for problem 1.1, is that right now I'm telling you these two types of equations, slope-intercept form and standard form, they're the exact same type of equation. It's just in different forms. So what we're going to look at is, for part A, is there's been some students that did some work to try to go from one form to the other, and we want to look closely at their work. So let's take a look. All right, part A. 4 students tried to write 12x plus 3y equals 9 in equivalent y equals mx plus b form. Did each student get an equation equivalent to the original ax plus by equals c form? If so, explain the reasoning for each step. If not, tell what errors the students made. All right, here we go. For Jared, so the original ax plus by equals c form is here. 12x plus 3y equals c. That's actually the same one we have for all of them, so let's take note of that. So first thing I notice in step 1, notice how it says 12x here, but then all of a sudden there's a minus 12x here. So what I think what happened is there was a subtraction of 12x from both sides. That means it would cancel here and then end up over here. So now we have 3y equals negative 12x plus 9. And then all of a sudden this 3y becomes a y. The 12 becomes a negative 4. The 9 becomes a 3. And I think what happened is that all of it, both sides were divided by 3. So we're down to y equals negative 4x plus 3. All right, so let's look at Molly. This one looks like they did a good job here. Let's look at Molly's. So same process. So the first thing to do, they're subtracting the 12x on both sides. I got it in this end. So now I've got 3y equals 9 minus 12x. That's okay. Same thing as over here. And they did a divide by 3. So they divided by 3. They did 9 divided by 3. Got that. And they still have the negative 12x, negative 12x. It looks as though this one, Molly did not divide everything on both sides by 3. So I believe Molly's is incorrect. Okay. Let's look at Mia's here. We got a 12x plus 3y equals 9. And automatically she goes down to a 4x plus y equals 3. And I wonder, instead of moving that 12x over, I think Mia actually divided by 3 first. You see that 12 goes down to 4, 3 would go down to that 1, and 9 goes down to 3. So I think she divided everything by 3 first, and then reordered this here. So then she did the minus 4x on both sides, and then put that in front here. So Mia, I agree with on hers there. And then Allie specifically, same process. So she's subtracted by 12x on both sides, and then went from the 3y down here. So then it did a division of by 3 on everything on both sides, and then reordered everything here as well too. But it looks as though something is different here. Notice how it's 3 minus 4x. She just flip-flopped these and left the minus. And these here, the minus sign or the negative sign would come with that 4x. In this case is not right. So she reversed them, but this minus should be in front. This should be a plus 3. So in this case, Jared and Mia are the only ones that are correct. Allie was really close, but she didn't bring the sign of the 4x with her. And this one, Molly, she forgot to divide by 3 on everything. All right, so I hope that made sense, looking at all those students and their work that they did on moving from standard form to slope-intercept form. But now in part B, we have a chance to actually do that work ourselves. And we're going to talk through some of those exact same strategies as we make those moves ourselves. So let's take a look. Here we go. Write each equation in y equals mx plus b form. And notice all these guys are already preset in the ax plus by equals c or standard form. So here we go. All right, so here's what we want to get here. This is what we're looking for. We need to have y be by itself on the left, and we need y to be positive. That means we need everything else to be moved. So let's go ahead and start off by doing that. Let's move that out of there. And let me see if I can find, yeah, this. So if I do minus x and minus x, this would cancel. I have negative y equals negative x plus 4. Okay. Now remember, we need our y to be positive. So in this case, what we're going to do is I'm going to end up getting rid of that negative 1. So I'm going to divide by negative 1 here, and divide by negative 1 here, and divide by negative 1 here. So this now is going to become a positive y equals, this becomes a positive x because negative divided by negative is going to be positive, and then 4 divided by negative 1 is going to be minus 4, and that would end up being that new formula. All right, number 2, 2x plus y equals 9. Same process. We got to get that y by itself, but it's already positive here, so it'll be a little bit smoother here for us. So I need to get that 2x out of there, minus 2x, minus 2x. This is going to be gone. Y equals minus 2x plus 9. And in that case, there's nothing else to divide by. This is already a positive y, and you guys don't have anything in common, so we're all set. So this is done. All right, number 3. 8x plus 4y equals negative 12. Now, right away, hopefully you're catching that each of these numbers do have a greatest common factor. And that's going to be 4. And you can also see what that will be because it's also with the y. So I'm actually going to divide by that 4 at the end. So let's go ahead and do that regular work of moving things around. So I'm going to do my minus 8x here, minus 8x here. This cancels. 4y equals, I'm going to have negative 8x minus 12. Remember, we don't subtract these because these are two different kinds of numbers. That 12 and the 8x, they can't even go together, so we can't do that. Now we have to get that y by itself without a number other than 1 in front of it. So we're going to divide by 4 here, divide by 4 here, and divide by 4 here. So 4 divided by 4 was going to be a plain old 1y. Negative 8 divided by 4 in that case would give us a negative 2x, and then negative 12 divided by negative 4 is going to be a negative 3, and that is going to be the answer for that one. All right, I hope those weren't too bad. I got to admit, like 1, 2, and 3 on part B are pretty good, but number 4 really throws us for a little bit of a loop because they're putting so many more variables in there. So watch carefully as we walk through this. The answer is not going to look like we would normally see it. Let's take a close look at what it's going to look like. Here we go. All right. C equals ax plus dy. Now before we do anything, look, just notice what they did. They just reversed what side everything's on. So if I can leave the y by itself over here, it'd be the exact same thing as having the y by itself over here. So here we go. Let's take a look. First of all, I'm going to get that x out of there, right? So minus ax here, minus ax here. And then from there, what I'm going to actually do is cancel this. So I can have here c minus ax equals dy. Hopefully you guys see that. This is the same process we'd have here. Like if this c was that 12, and the a is like the 2 here, okay? Our last move is we want that y completely by itself. So what we need to do here now is do a division. And so what we're going to do is we're going to divide this side by d. And actually we would divide all of this by d as well. This is going to cancel. And we could actually leave it this way. Or we can say y equals c minus ax, and be c divided by d and ax divided by d. So this is kind of closer to the more formal version of what that would look like. Hopefully that was clear. We'll have a chance to practice this some more, but I know number 4 is a little tricky. We have more of the same here specifically now in part C, but we're going to go from slope-intercept form to standard form now. So let's take a look at that. Here it is. C. Write each equation in ax plus by equals c form. And notice how each of these are, this is slope-intercept, but some of these are all in different places. So we'll have to work with this as we go. All right, so notice right now, y is by itself, and we want to have the x and the y stuff all on the other side, and that 5 is going to be like the c. So you're going to move that minus 3x out. That's the only step we have. Plus 3x and plus 3x. So this is going to be gone. So I'd have a 3x plus y equals 5. And that's all we do for that one. All right, here we go. Real big one. So if you remember, what we ended up doing at the very end of the other method of getting from standard to y-intercept form is we would end up dividing by whatever variable was here. This is going to give us a little bit of a clue that we have this by 4 on both sides. So what we can do is multiply everything by 4 to get that 4 over here with the y. So watch this. So multiply everything over here by 4 over 1. Multiply this times 4. So you'll see this will become a 4y equals. Now if I look at this, this is going to cancel here. So I'm left with 3x. And this is going to cancel there as well. So I've got a plus 1. And then after that, I just need to get that 3x out of there. So I do minus 3x here and minus 3x here. This is going to cancel. So my final setup is negative 3x plus 4y equals 1. And that's all we do for that. All right. So this one is in neither form. This is neither slope-intercept form nor standard form. But we always want to get the y and the x on the same side. So since x is already over here, we can just move that 2y over. And that's all that we would have to do. So minus 2y and minus 2y. That cancels. So I would have x minus 2y equals negative 3. And that's it. We're done on that one. All right, number 4. Another one of those that look weird. Well, notice that we already have the gx and the fy already together, and that's fine. We can just get those guys all on one side over here, and then you get this 3 out of there, and it's not going to be a big deal at all. So let's do that first. Let's get that 3 out of there. So minus 3, that's going to be gone. This is going to give us a negative 18. So now I would have fy equals gx minus 18. Need to do subtract the gx and subtract the gx. So that would leave me with negative gx plus fy equals negative 18. And that's all we would do for that.